Hello everyone, and welcome to this second in a series of 3 webinars presenting ATTO's XstreamCORE bridge products. My name's Chris Elson, and I'm one of the product specialists here at Global Distribution, and I'd like to welcome Matt Mercurio to the presentation, who will be giving the technical presentation in a few moments. Matt's a Senior Product Specialist, Customer Engineer from ATTO. In the previous session, presentation, we spoke about what the bridge product is, what the XstreamCORE bridge is, and some common user cases and applications that it's used for. But in this session, we'll be taking a much deeper look into the nuts and bolts of the product and how it actually works and comes together. And on the 16th of September, so in a few weeks' time, we'll be having a third presentation where we bring together a few other manufacturers to present how you can use the Xstream bridge to bring together storage as a service with Data Core and with Western Digital. So that will be well worth looking into as well. And I'd like to also draw your attention to just below the viewing screen. There's an opportunity to ask questions. So if anything does occur to you during the presentation, then please feel free to ask any question, and we'll address those at the end. Okay, so without more further to do, I'll invite Matt to give his presentation. Thank you.
Thank you, Chris. We'll kind of skip past these first couple of slides. Here's our pictures in case you can't see us on video. As Chris mentioned, I'm a senior customer engineer at ATTO Technology. I've been with the company over 18 years now, so I'm pretty well versed in this product line as well as the storage industry. Today, like Chris mentioned, we're going to take a technical dive into the XstreamCORE bridge product line. We're going to look at a little bit of the nuts and bolts, some of the features that we have that are underlying into this product. Next week, or in 2 weeks, we'll actually go into one specific use case that we're working with Data Core on. That'll be very interesting, so I do recommend coming to that presentation as well. Just to recap what we did a couple weeks ago, XstreamCORE is what we call an intelligent bridge. And we'll talk about that a little bit more detail as I go through the technical side. It translates SAS to Fibre Channel or SAS to Ethernet. And again, we'll talk about, or I will talk about the specific models that we offer, which you see right there on the slide. And its purpose to accelerate the data. And one of the things with bridging technology is when you're translating from one language to another, SAS to Fibre Channel or SAS to Ethernet, you're bound to add latency. And so we've designed some technology that actually removes that latency that is introduced from the translation. Some of the use cases that they talked about for this product, it's generally used in software-defined storage type of environments, metro cluster, stretch clusters. If you want to add Ethernet to SAS tape, it's a lower cost option than, say, buying a native Ethernet SAS tape drive. It's used to disaggregate storage from the server so that you don't have any single point of failure, and expand storage for blade servers. So one of the bigger ones that we've had customers come to us is their blade servers could only have 1 or 2 drives embedded onto them. If they need to expand outward with their storage, they really had no solution. This gives them that high-performing solution. This product can also be used to repurpose your old SAS storage, because you can not only just connect just JBODs or just a bunch of flash, but you can also attach RAID controllers as well. So if you have older RAID systems that you want to share out to multiple clients, that's a good point for that. And then, of course, it adds management capabilities to SAS JBODs. As you know, SAS JBODs are not very don't provide a lot of feature sets like RAID-based enclosures. So our product can actually add some value to those JBODs as well, and we'll talk about that. So First, we'll go over the basic function. As most of you probably know, the primary function of a bridge product is to translate from one protocol to another. So in this case, we're taking SAS storage and translating it to shared storage protocols such as Fibre Channel and iSCSI Ethernet. So what do these bridges do that we offer? As I mentioned before, it shares data to multiple hosts. So it takes any of your direct attached storage, and now you can share it to 1 to up to 64 different clients. Our products move data fast, and we'll go through some of that in further slides about our acceleration engine that handles that high performance and low latency. We also have some technology in there that can help offload work from your CPU. So if you need to do transfers from one storage device to another, you don't need your server's processor and memory to be involved in that process, and it can be used for other operations while you're doing the transfer. This product supports not only hard disk drives, but SSDs and tape drives, and it does so with minimal latency. It can also be used to, and you've seen this in the use cases from our presentation a couple weeks ago. It facilitates connecting data centers. That's where the metric clusters come in. So there's a lot of long distance use cases that these products could be used in. It's one of the bigger reasons why many of our partners came to us to connect SAS tape so that they can do remote backups from multiple servers to their tape drive, right? Tape drives and tape libraries. It extends the life of your existing RAID storage, and I talked about this a little bit in the previous slide. You can take old 3 gigabit, 6 gigabit, even 12 gigabit SAS RAID controllers, reuse it, and share it to multiple clients. This has actually been found to be very useful in VMware environments where most of these RAID boxes were direct attached to their servers. And ever since we've been able to qualify our bridges with VMware, now users can share that storage between all the physical servers, and it speeds up processes such as vMotion when you're moving one VM from one physical server to another. Used to take hours, now it takes minutes to do that if you use one of our storage controllers in there. And then, of course, it's got an open and modular design. And the reason for this is we've been building these bridges since as long as I've been here. And as technology grows and changes, you're going from SCSI to SAS to Fibre Channel, and different speeds of Fibre Channel, and Ethernet gets introduced. And we get a lot of customers who are like, well, I'd like to, convert this protocol to this protocol and this protocol to that protocol. Our modular design, open and modular design, makes it easy for us to be nimble, to be able to build up a product quite quickly if there's a new need. So if someone were looking for Fibre Channel to Fibre Channel or SAS to SAS, we could do that. So the XstreamCORE bridges have 2 control engines. We did this to separate the data path so that we can accelerate that data. And then on the other side, we still need to be able to do the management functionalities, any reservations, other low-level SCSI stuff that doesn't need acceleration. It gets done in our eCore engine. We learned as we designed this product that we have to separate that, so that because the data in the XCORE engine was moving so fast that the eCore, the other processes were not getting time. So we actually had to separate those processes through 2 engines. And this is how we are able to do the high acceleration that we do. And you'll see that in a later slide as well. So what does the XstreamCORE bridge compare to? Normally, when someone wants to convert one protocol from another, they might buy a low-cost server, put a SAS HBA inside to connect their storage, and then share it out either through a network adapter or a Fibre Channel adapter in target mode. This obviously could be a lower cost solution to what we're providing, but as you'll see, the performance of a server solution like this is much less compared to the XstreamCORE bridges. Typically, a server that you build up in this environment, if you're in the IT environment, when you're talking IOPS or input output per second, these servers max out probably about 400,000 4K transfers. 400,000 IOPS at 4K transfer size. Compare that to the XstreamCORE bridge, which is 3 times faster. Our bridges can go as fast as 1.2 million IOPS at 4K transfer sizes. When you combine bridges together, which is often done because you're now going from, they're used in pairs in metro cluster environments, site to site. Now you're talking over 2 million IOPS between the two if you're able to aggregate them using your software-defined storage. Now we'll go through each model that we offer today. The first one is the XstreamCORE 7550. As I mentioned before, these are all built on the same platform, so I'll actually talk a lot about some of the features of the 7550, but they will spill over to the other models as well. So I won't bore you on the future slides of going through every bullet point. We'll talk mostly on the 7550 at first. This is what it looks like on the back side. It has dual power supplies, dual fans, 4 16 gigabit fiber channel ports, and 4 physical 12 gigabit SAS ports. So that's up to 16 PHYs if you break it down, each physical port broken down. It has 2 Ethernet management ports as well as 1 serial management port as well. The key thing I want you to pull out of this slide, all these product lines, the hardware maxes out about 6,000 megabytes per second. But the key here is the maximum IOPS is 1.2 million. It's really, really fast. The other key point that I'd like to discuss here is the amount of storage that you can put behind these devices. Up to 960 drives. Now, out of the box, if you were to buy this as an end user, we say 240, because when you connect up to 960, and you're integrating it in with your software-defined storage and everything, we always recommend that you run through a proof of concept or a test cycle first when you're using that many drives, just to make sure that there are no problems added in by the other components on the network. But these devices can support up to 960 devices. It says drives, but it can be tape devices through expanders. It could be SSDs. It could be hard disk drives. And this is where this product gains more value. If you're going to just put one JBOD array behind this controller, it's really not worth it for you. But the more storage you add to this, the more value you get out of it. And again, you don't lose any performance because of the acceleration engines put into these products. Here is an eye chart of some of the key features of this product, and these are mostly shared. I'll go through the bullet points of the other products in less detail. This one I'll go in a little bit more. We talked about the 4 fiber channel ports and 16 12 gigabit SAS SATA PHYs that are available. These are powered by the MBLX chipset and the PMC chipset on the SAS side. We have an integrated ARM processor, and these are used for the XCORE data acceleration and the eCore control engine. The XCORE uses 4,000 megabytes or 4 gigs of DDR4 memory, and the eCore needs less memory for its process, so it only is using 1 gig. One of the keys here is it controls it allows you to connect up to 64 initiators. If you don't know what an initiator is, it's 64 host systems. So you can have up to 64 servers or workstations connected to one of these boxes at once. and sharing out to your storage. We talked about the number of devices. We say 240 for an end user, but if you're talking OEMs or system integrators, we can get you to up to 960 on that. And then, of course, we talk about single and we offer dual hot swappable power supplies. It has its management port and 2 gigabit Ethernet management ports. And it does support dual firmware images, so that if you're doing a firmware update, you don't brick the box if something goes wrong or fails along the way. And one of the nice things about this is it's a battery free, even though it contains persistent logs. And we do this through persistent memory modules on board. And we'll talk about the debugging capability of these products in later slides. It's quite useful. The next model we talked about is the 7600. This is the same as the 7550. The only difference is it's 32 gigabit fiber channel and it has 2 32 gigabit ports. The overall configuration, as you can see, is pretty much the same. So no differences there. Again, up to 6,000 megabytes per second. Again, 1.2 million at 4K transfer size IOPS, and up to 960 devices. One of the things I didn't mention on the 7550, while we sell these as a rack mountable unit, as you see in the picture, if we have any system integrators or OEMs who are looking to build their own storage box around our technology, we do actually offer a embeddable module, and that's actually a micro ATX type main board. So it's pretty standardized for the chassis out there that most people use. Again, the eye chart comes back. I'm not really going to go through this too much here because it's just like the 7550. Again, the only difference is that the fiber channel speed is faster and the number of fiber channel ports is less. Last but not least is our Ethernet model. There's actually 2 model versions here. We call it the 8200 and the 8200T. The T stands for tape. 8200 on its own supports all devices, whether it's SSDs, hard disk drives, or tape devices. I didn't mention this before, but these products even support optical devices like Blu-ray. So you can use those as well, connect those as well to these and share them out to your servers. The T model is only designed just for tape drives. So we have a lot of solutions where you're connecting, or we have a lot of partners who are qualified the tape model to connect large tape libraries, SAS tape libraries, to the back end and share them out through Ethernet to the servers. Again, the platform is the similar. We're able to maintain that high performance, 1.24 million IOPS, 960 drives. Again, same form factor of the board. It's just the different connector types, whether you're talking about fiber channel or your Ethernet. And the feature set is very similar as well. The 8200 is based on 40 gigabit Ethernet. So you can split that up down to your 10 gigabit clients if need be, or you can shoot it straight out to 40 gigabit, any which way you like through Ethernet using a switch. We use a Mellanox controller on this product for the Ethernet side. And the memory configuration is a little bit different. We actually stacked up the memory to 6 gig because Ethernet transactions tend to use more memory and processor time. So we had to increase we had to beef up the memory in order to maintain that high performance on the Ethernet side of this product. Some more features that we'll talk in more detail about on following slides that are shared. This is built around an ATTO embedded operating system. This operating system gives us that flexibility, like I said before, to be able to build up a bridging product based around almost any protocol out there that we support today. We have a patented technology put into this product called Drive Map Director, and I'll talk about that in more detail as well a little bit later. Management can be done through a web-based that's built right into the controller, or command line based that you can access through SSH or through your serial port. We talked about the dual firmware image. No batteries we talked about. This is very useful for if you're shipping across country borders and they have different environmental regulations. There's no batteries on there. Very large event log that holds up to 40,000 events. It does core dump analysis. So if there is a major issue or catastrophe, a hang up, the core dump can be initiated to take a snapshot of everything that's going on around, from the server side down to the targets on the back end. It'll give us a full picture of what's going on at the time of the problem, and it has, especially with a lot of our existing customers today, become critical in helping solve issues quickly for them. We also, for deeper issues, if you need to look deep down, if you're having drive latency issues, we actually have a built-in Fibre Channel and SAS protocol analyzer right in this product. And then, of course, we have statistic reporting, and we'll talk a little bit later. We actually have a performance tool in here that's really good at determining drive latency. If you have failing drives, if you have misbehaving drives, that tool can be quite useful. It does support multipathing, and because of the embedded, we allow embedding this product. We do have OEM customization as well, and we'll talk about all that. This slide is kind of a repeat. I apologize. So first, we'll talk about the ATTO embedded operating system. This was designed probably 20 years ago by ATTO in their first bridges. It basically allows the integration of almost any protocol. Like before, in early days, we were doing SCSI to 1 gigabit Ethernet, SCSI to Fibre Channel. We even did a SCSI to SCSI at one point. This is the operating system that everything is built around, makes it easy for us to integrate. It acts as the translator from one protocol to the other. It manages the acceleration, and it also manages all the other underlying features of the product. The latest versions of our products, so the current products that we have that we just went through, we've actually put this embedded operating system on top of a Linux kernel now, with the intent of, if we have certain OEM customers that want to be able to embed, say, their application into the controller intelligence, we have the ability to do that now. If we get your engineering team working with ours. Now, Drive Map Director. This is the patented technology I was talking about. This is a way where the controller actually talks to a JBOD or JBOF, just a bunch of flash. It talks to the expander inside those boxes, and what it does is it queries the expander to learn the topology, where each drive sits, which slot number. If you have multiple shelves daisy chained together, it also will learn the layer it's at, whether it's the first person in the stack or the last storage in the stack. And then what that will do is it'll map it to a Fibre Channel 1 in the same order, so that if you have to replace a drive, you don't have to remap it. It already just goes to the same slot. It makes it easier to find a failing drive if you especially in a data center situation where You have one guy monitoring externally, and he's going, hey, drive 15 in chassis 3 is failing. He sends a guy into the data center to go and replace drives just with that information, and all he has to do is replace the drive. There's no management needed to get that new drive back up and online because it's there already presented to the host systems. So this obviously it lowers your operating costs, and it definitely makes it a lot easier to manage multiple shelves of storage. And when you're dealing with 960 devices behind this bridge, it's very helpful. Another feature that we've added recently is host group mapping. So this is actually a feature that you normally might find only in switches. They call it zoning, where you can tell certain storage to only be presented to certain clients. So drive A and B I only want presented to server A, but drive C and D I want to server B. We've integrated this into the bridge as well, host group mapping. So because we had a lot of customers using these products where they didn't need to use a switch, but they needed the ability to control who sees which storage. Extreme View is the web-based management interface that I said was built in. It's as simple as typing in your IP address into a web browser, and the web GUI will come right up, give you remote management to the product from wherever you are to manage this product. It provides almost everything that you can get through the command line interface. So you can manage your Ethernet ports, your Fibre Channel ports on the Fibre Channel versions. Set up remote management for SNMP or email notifications. Your mapping can be done in here, and even if you want to get down to the low level, if you want to have high control through the command line, there's even an advanced tab on the web GUI where you can actually issue command line commands as well. This can be customized. So as you see it today is ATTO XstreamCORE. If you were an OEM and you wanted to integrate this into the system and you wanted to rebrand it so that it said, company X up there instead of ATTO, and if you have a different model name, we can do that. So we can change the inquiry strings, we can change the names so that they show up differently to your operating systems. We can even we've even gone to the level of we can change the behavior of a reserve release or certain SCSI operations to the backend devices based on how your software-defined storage works. For the advanced user who doesn't like web-based GUIs, we do offer everything through CLI as well. I mentioned before, it's done through Telnet. We do have secure protocol support as well, SSH and HTTPS, or the serial port. The nice thing about the command line interface is if you want to automate some operations, you can script this. You can integrate this into your application using CLI commands. One of the other ways that CLI can be accessed is what we call in-band through Fibre Channel. That means this is probably the most secure because you don't have to deal with network hacking or anything coming in from that way. When you're on a Fibre Channel network, it's a closed network. So if you're managing the bridge in-band using your software on the host side, then you have a total secure management interface to the bridge. So now we'll get into some of the advanced diagnostics. The bridge does have, it holds up to 40,000 events. It also does have onboard analyzers for SAS and SATA, for SAS SATA, as well as Fibre Channel. The Ethernet model will be adding support for TCP dump down the road, so that's another tracing tool that will be available to users. The analyzers hold less events, but when we're using the analyzers, we tend to be focused on a specific area, so we turn it on and off when we need to capture a certain picture, if you will. It does have a real-time clock. It will get time from your time server so that everything's synchronized with your servers, and we will stamp each event with a time clock on there so that it's easier for debugging. Everything is backed up by NV cache, so this is where we don't have a battery anymore for maintaining the events. We do this through NV cache. We track configuration changes. We track connections to the jibs. We log events that are listed here, but we also log drive errors or anything that's coming from your back-end storage device. We're logging in this event log because we found that the more information that we can pull in, if a problem is found, if it can be found in one area, then if we can keep it all in one area, it's easier to resolve. And then we talked about the core dump error analysis. It does have this firmware core dump ability that gives us that total snapshot of the events leading up to and into a problem so that we can actually resolve an issue much quicker using this. Pretty standard with most storage controllers, maybe not with JBODs, and this is actually where our ATTO bridge adds value, because with JBODs they don't have remote diagnostic, they don't have SNMP, they don't have email notification or in-band notification. We can actually report SCSI drive errors, device online, offline, hardware errors, illegal requests, etc. through our product and send that up through SNMP notification, email notification, or in-band. Now this is a fairly new tool. This is real-time performance analytics. What we found during our development of our acceleration engine was that it was so fast that software-based performance tools really couldn't show us the details level of detail we needed. So we actually created a hardware performance engine that can actually do this. Early stages of this, it was very command line driven, hard to read, but we are migrating it right now to a nice GUI like you see in the screenshot on the right. This is first going into a new generation product coming out within the next year, but we're integrating this into the current product lines also within the next year as well. So this will be a very useful tool, not only for OEMs, but within the next year, even end users can find use in this product. I will tell you from personal experience that this performance analytics has actually saved one of our biggest OEMs from losing a customer over a drive issue that they had. They had a major issue that they couldn't pinpoint whether it was coming from the host, coming from the bridge, or coming from the storage. And this tool actually was used to drive it down to the actual physical individual disk drive that was causing the problem, and pointed out some of the key problems to help our OEM's engineers resolve the problem in their drive. This is the XCopy is what we talk about when we're doing the offloading transfers from your server. I talked about this in an earlier slide a little bit. The technology we use to do this is XCopy. It's a SCSI command set. So a normal a transfer operation, say if you want to move data from a source drive to a destination drive, the server will send down the request. The source drive will send it back up through the server and down to the destination drive. So the server is always involved in a normal situation under these types of transfers. Well, that takes away your CPU and your memory that you might be using for other applications or processes on your server, and that could be a bad thing. So XCopy is a technology that we've put in here where the server can now say, hey, I want to move data from this source drive to this destination drive. Here's the data I want to move. Sends it to the XstreamCORE bridge, and now the XstreamCORE bridge goes, okay, we got this, you can go do something else. And now we do all the processes directly from the source device to the destination device without impeding on the server itself. The only time we have to tell the server anything at all is when the transfer is done. This actually technology, your host systems do need to support these XCopy commands or data moving. Right now, VMware is the only one that really has the technology to take advantage of this. But it's quite useful because there's always a lot of data migrations going on in VMware environments. SpeedWrite is a patent pending, I believe, technology that we wrote actually a long time ago for older tape drives. If you're familiar with the difference between a tape drive and a disk drive is designed where you can actually queue up many commands to it, so that when it's done processing a write command, there's another ready to go for the disk drive so that it can maintain a high performance. Tape drives don't operate like that. They can only handle one command at a time. Their queue depth is 1, so it limits their performance. So what we had designed years ago for older tape models, and we're finding it to be beneficial for even the new models today, especially with our acceleration engine, is that we've actually created SpeedWrite, which queues up more than one command. We actually increase the queue depth to 2, and how we do this is we actually respond for the tape drive. So a normal operation would send a write down from the server to the bridge, and the bridge would send it to the tape drive. And when the tape drive was done processing, it would send back an acknowledgement saying it was done or it failed, one of the two. So, but the server could not send its second write command until it received that information back about the first write command. With SpeedWrite, the server sends the write command, the bridge will pass it on to the tape drive, and at the same time as it passes it to the tape drive, it's also sending down an acknowledgement to the server to say, okay, we're done, send the second command. So now the second command's on the way to us. The tape finishes the first command, and we're ready to shoot at the second command. So as you can see, we're not giving it the tape drive a chance to rest, because now it has that second command before it has to wait for the next one coming from the server. That's SpeedWrite. Hopefully I did a good job explaining that. To me, the images on this slide always tell the story. So that's XstreamCORE technical features. We are actually going to play you a video now that shows you it's a simple setup video on how you would configure the bridge and map devices so that your host systems can see and operate with these devices. Now remember, these bridge devices use block-based protocols. So if you're familiar with direct attach, say it's connecting a SAS JBOD or SAS RAID array or SAS tape drive directly through a SAS HBA, you're probably wondering, well, if I connect it through these bridges, how do they show up to my system? They will show up the exact same way. And as you see in this video, how this is done is by mapping the SAS device to a Fibre Channel LUN. After the video is over, we will allow some questions. So let me play the video.
XstreamView is a single pane of glass remote management user interface used in configuration, monitoring, and management of ATTO storage controller products. Please refer to the manual of your XstreamCORE device for the default login credentials. The manual can be found in PDF format at atto.com/support. Please note it is best practice to change these credentials after the initial login. Please refer to the product manual for the most up-to-date procedure and requirements for the login credentials. Once logged in, we can see the status page, which gives an overview of the current settings applied to your XstreamCORE. In the panel on the left side of the screen, we can navigate to the Ethernet tab. This is where you can adjust settings for the data ports and management ports. Under time and date, this is where you can set SNTP settings, amongst other settings. The remote management tab is where you can adjust the DNS server address, SNMP configuration, and email configuration. The iSCSI configuration tab will show the iSCSI alias, which will assign a human-readable name to the system. Aliases may be 1 to 64 characters in length. The Manual Target Management tab is where you'll begin to map devices, as well as adjust settings for access control, access entry, iSCSI CHAP, amongst other settings. The Controller tab will show you environmentals and username and password information. This is where you can assign a new password to your XstreamCORE as well as a username, and see some information about operating temps, minimum, maximum alerts, and things like that. Certificate Management tab displays or sets the attributes used to generate the HTTPS certificate. The Firmware Update tab is where you can go to load a new firmware downloaded from atto.com support page. The Advanced CLI Configuration tab will allow the input of many of the CLI commands available to the XstreamCORE. Just enter help for a list of available commands. The Restart tab will restart your XstreamCORE device. And the Help tab will provide information for online help as well as where to contact tech support. First, log into the XstreamView web interface using the IP address discovered or configured in the previous video. It is recommended that the XstreamCORE 8200 is used on an isolated physical lossless network when using iSCSI. Spanning Tree Protocol, or STP, should be disabled on the switch ports being used for iSCSI traffic. This would mean ports connected to the 8200 and each iSCSI initiator. If you do need STP enabled, it is recommended that you enable the STP fast port feature on your switch. Please contact your IT administrator for more information. Click the Ethernet tab in the left sidebar. Under the Ethernet tab is where we can begin configuring both data ports. Please note that it is best practice to disable DHCP for the data ports. Please note when using both data ports on the 8200, they must be on independent subnets in order to achieve optimal performance and reliability. In this example, we will use the IP address 10.198.125.186. We will leave the IP gateway at its default, and we will set the subnet mask to 255.255.0.0. Here we can adjust the Ethernet speed to auto-negotiate or set to 10 or 40 gigabit, and we can also set the MTU size for standard or jumbo frames. Once your settings have been configured, click Submit. In this example, we'll be configuring 2 data ports. So on data port 2, we'll disable DHCP, and we will enter IP address 10.197.125.186. Take note that data port 2 has been assigned a different subnet than data port 1. The gateway will remain at the default, and the subnet mask will be 255.255.00. Once your settings have been configured, click Submit, and your data port has been configured. If you would like to manually set the management port, you can disable DHCP and set the IP address, gateway, and subnet mask accordingly. Next, we will map devices to the XstreamCORE 8200. Once logged in, navigate over to the Manual Target Management tab. And here we can configure the iSCSI targets. There is a default and an already assigned iSCSI target. The default will show any devices that were attached to the 8200 prior to it being powered on. In this case, we have a SAS JBOD attached to the 8200, so we can see the various hard drives that are installed in that JBOD. And if we toggle over to that SAS JBOD that was automatically discovered by the 8200, we can see the devices that are already mapped on the left-hand side, and on the right-hand side, any unmapped devices. Now, to map a new device, you simply drag an unmapped device from the right side into the left-hand column. And if you'd like to unmap a device, you simply do the reverse. You drag the device from the left-hand column to the right. And press Submit. And now your new devices have been mapped. Now, if we want to create an entirely new iSCSI target, we give it a name. In this case, we'll call it Test. That will create the new iSCSI target. And now we need to map devices to it. So under Test, we will click Device Maps. And we can see the controller of the SAS JBOD already mapped as well. And we can drag over hard drives that are in that SAS JBOD to map them to that new iSCSI target. Press Submit once done, and your devices have been mapped.
Okay. Matt, thanks ever so much for sharing that information with us. Just to look at some of the questions. So just a couple of questions have popped in. First off, do the ATTO bridges provide built-in RAID functionality?
That's a good question. We do not provide built-in RAID functionality. This was a design decision because if you're familiar with ATTO, we actually used to do RAID through a PCI-based controller. And what we've learned over the last couple of years is that the capacities of the hard drives have become so large that hardware RAID controllers have become inefficient, especially on a drive failure, where if it has to rebuild up, it will take days. And this is what we're finding. More and more people are going towards software-defined solutions because they can manage these larger drives better. So these products were really designed to complement software-defined storage solutions. And that was the reason why we don't build in RAID right there. So
okay, and I guess next week, so on the 16th, we can find out a lot more about how ATTO supports software-defined storage solutions.
Exactly. The DataCore solution is a perfect example of how everybody's trying to disaggregate your software component from the servers from the storage, so that you don't have that single point of failure.
Yeah, absolutely. Okay, and then the second question, simple question really, I guess. What operating systems are supported by XstreamCORE?
That's a good one too. The bridge itself is actually operating system agnostic, meaning that you can connect it to any operating system as long as you have an HBA, Fibre Channel HBA, or Ethernet network adapter that is supported in your operating system. Now, for the 8200, you also need to have a iSCSI initiator available on your operating system as well. So we have customers who install this in Linux environments, Windows environments, even Mac OS. You can use this in a Lumos or FreeBSD. all of those provide connectivity through Fibre Channel, HBAs, or network adapters, and with iSCSI support. So again, as long as you have those requirements, this bridge will work with any operating system.
Yeah, no, absolutely. Sounds really, really quite very flexible. Okay, so I mean that's it for the questions. It just falls for me to thank Matt for joining us this afternoon or this morning, indeed, and giving us the benefit of his experience and that information, that fantastic presentation, and to thank everyone who's attended for joining us on this webinar, and of course invite you all to the third webinar on 16th of September. So hopefully we'll see you then. Thanks very much. Bye-bye.
Cheers.